Hello, in this video we're going to discuss the new real-time option in the FSW Signal and Spectrum Analyzer. This is option K160. So first let's start by just using the normal Spectrum Analyzer mode on the FSW. We can tune to a center frequency of 1 GHz and a span of 160 MHz. Notice right now we have an unmodulated signal, so we can always see it in the spectrum, and we can go up to the SMW vector signal generator and go to the pulse modulation section. So in the pulse generator portion, you can see that the pulse width is set to 1.7 microseconds with a pulse period of 1 second. We can turn the state to on, and notice now back down on the FSW we're no longer catching the spectrum. So this is because the pulse is too short for the FSW to sweep and process the data. So if we want to see a signal like this in the spectrum, we would have to go to the new real-time spectrum mode. So notice we're catching it every time now in the spectrum, and we can make a few changes on the display. First thing to note is our span is 160 megahertz, so this is the full real-time bandwidth of the K160 option. We can change our bandwidth span to resolution bandwidth ratio to value of 6, and I'll explain in a second why we do that. We can bring in the persistent spectrum on the display. So this is a spectrum that keeps track of all signals seen over time, and we can easily change the color mapping by touching on the color bar and changing the mapping. So you can see now it's a little more clear to the eye to see what's going on. So as explained before, we changed our span to resolution bandwidth ratio to 6. Now this gives us our shortest FFT time window, which gives us our best probability of detecting short events. So what I mean by that is, remember we had a 1.7 microsecond pulse. Well, when we're set up in this mode, we can catch the full power. So remember we had a 0 dBm power setting for the pulse. Notice every time in the persistent spectrum, we're hitting this 0 dBm level. So we're getting completely reliable power measurements on this narrow pulse. And we can look into our spectrogram display down below, and we can see every second we're getting this pulse reliably. In the center, the color is red, showing we're getting 0 dBm. And this is something that's very unique to the FSW, being able to get full power measurement on a very narrow pulse signal, as we're showing here on our SMW. So that concludes the demonstration. Remember, we went over the new real-time option, some of the user interface features, the 160 megahertz bandwidth, and what's called the probability of intercept, which we showed here on a 1.7 microsecond pulse. Thanks for your attention and have a nice day.